I'm going to tell you that when the nature of the response variable is continuous, of course, we use linear regression. We use analysis of variance. Of course, the t-test and the like actually fall under what I call the general linear model. I'm going to say that again. When I say general linear model, what are the tests that am I referring to? I'm referring to linear regression. I'm referring to analysis of variance. I'm referring to t-test. I'm referring to, situation where the response is continuous. Okay, so we call that general linear model. I'm going to repeat that. Very, very crucial. I need you to take note of these. When I say general linear model, I'm actually referring to those tests that assume the response variable continuous. What are these tests? You remember your t-test. Assume a response variable to be continuous. Your analysis of variance test, your linear regression, and so on like that. Let me also tell you something about general linear model. They all have these 4 assumptions that I'm going to mention. They all have these assumptions that I'm actually going to mention: linearity, constant variance, normality, okay, linearity, okay, constant variance, okay, normality, independence. What am I talking about? I'm talking about general linear model. I'm talking about assumptions of the general linear models. And that's why when you take a look at the analysis of variance we've been doing, the linear regression, we always talk about all these assumptions. Does that make sense to you now? That's what we call general linear model. But what do we mean by generalized linear model? There's a difference between generalized linear model and the general linear model. Now, I'm going to tell you the meaning of the generalized linear model now. The generalized linear model actually generalizes linear regression, okay, to allow the linear model to be related to the response, via what I call a link function. Via a link function, I'm going to say that again. The generalized linear model, okay, generalizes. Look at the word generalized. Generalized. So it generalizes linear regression, okay, now to allow the relationship between the linear model, okay, and the response, okay, and that very relationship is being captured by link function. And you know what link function does, right? I'm going to tell you what link function actually do. The link function transform the probabilities of the level of categorical variables. I'm going to write that now. What link function, I'm talking about generalized linear model, right? Okay, now I want to tell you, I said the generalized linear model, I say now this generalizes linear regression, okay, allowing the the linear model, allowing the linear model to be related to response, okay, via link function. Let me see if I can get another marker. This is not I think I'm going to manage. Oh, can you see what I'm writing on the board, right? Okay. Now, via link function. Okay. Now, what is the function of a link function? The link function allow the magnitude, allows the magnitude, okay, of each measurement, okay, to be, to depend on its predicted value. Now, let me tell you what the link function does. The link function actually transform the probabilities of the levels of the categorical variable into a continuous scale. You know, when you are working with if a situation where the response variable is, it's not continuous, we can now use a general linear model anymore. Okay, which means we need to use a generalized linear model. What the generalized linear model is going to do is going to transform the probability, okay, of the levels of that categorical response, okay, into a continuous scale. Okay, and that very continuous scale will be unbounded. Okay, it's going to be unbounded. I'm going to write that now. It's going to be unbounded. Okay, so a link function transforms the probabilities of the levels of categorical response into a continuous scale, that is unbounded. Of course, you know, the categorical is bounded. You know, remember the other time when we're dealing with the 0, 1, right? You know the reason why linear model cannot be used. Because linear model cannot be used, the prediction is going to go over the range of 0 and 1, even though other assumptions can be fixed, but there's no way the whatever efforts you do cannot restrict the range into 0, 1. And that was why we go for other form of a model. Let me tell you this: logistic regression, okay, and other variants of logistic regression, they are classified under generalized linear model. So I'm going to say this again. The general linear model that you see, the general linear model is actually talking about situation where the response is continuous, like general linear model. An example of such: linear regression, analysis of variance, t-test, and so on like that. And they all have assumptions of linearity, normality, constant variance, independence. But what if in a situation where the response variable is categorical, then we cannot use general linear model anymore. What do I mean by not using general linear model? It means I cannot use ANOVA, I cannot use linear regression, I cannot use t-test, I cannot use any method, okay, that assume linearity, normality, constant variance, okay, and independent. That's what it means. Does that make sense? Now, by generalized linear model, okay, that we enable the linear model now, it's going to generalize the linear regression and enable the linear model to be linearly related to the response. But how can that possible? That will be possible by link function. And what is the function of the link function? The link function will now do a job. Okay, I know you response, you are categorical, you are bounded, but I'm going to do something to make sure you are unbounded. Because it is only when it is unbounded that you can now finally apply linear regression. Even in logistic regression, we apply linear regression, but a link function has already done its job. What is the function of, what is the job? What is the role of link function? The link function will transform, okay, the probability of the levels of the categorical response into a continuous scale. Because before you can apply linear regression, you need a transformation to a continuous scale. Any question? Exactly what we're doing now. Okay, so What I'm trying to say in essence that, the logistic regression that we've done, okay, and the variants of logistic that we're going to do, they are all captured under the generalized linear model. The fact remain, the nature of the response was not categorical. We needed a link function that transformed that into a continuous scale. But you know what? In the end, we still use linear regression. But the linear regression was possible after transformation to a continuous scale has already been achieved. Okay, I want to go back to review a case, the case control study.